Hi everyone, myself Mr. VVSSR KRISHNA PH, and I am the course instructor for fluid mechanics and hydraulic machines. And today's my topic is what is a fluid and what are the properties of fluids. At the end of section, you will be able to write or perceive what is a fluid, classifications of fluids, and properties of fluids. So let's start with concept of fluid. This fluid mechanics is derived from applied mechanics, in which we will be studying the behavior of a liquid or a gas either in rest or in motion. If we study the characteristics of fluid under rest condition, then it is said to be a fluid statics. Wherever, if we are considering the fluid properties or characteristics in its motion, only when the pressure forces are not considered, then it is said to be fluid kinematics. If we consider the pressure forces also in consideration, then it is said to be a fluid dynamics. So this is the brief introduction between fluid statics, kinematics, and dynamics. In our syllabus, we will be dealing with fluid mechanics, which means under rest condition and also in the dynamic conditions. So we all know that there are three states of matter. One is solid and a liquid and a gas. A solid holds a shape and it will be in a fixed volume. And whereas a liquid will be in a container and if it is a free surface under a fixed volume. And it is a gas. If it is gas, it is a shape of container and it will be based upon the volume of the container, the quantity of gas will be. So just now we discussed what is the fluid mechanics and fluid kinematics and dynamics. So now what is a fluid? A fluid is a substance which has ability to act according to the shear force or the ability of a liquid to flow is nothing but a fluid. All liquids can be a fluid, but all fluids cannot be liquid. Why? A liquid is a state of matter, whereas a fluid is a parameter. A fluid is said to be a compressed and which has ability to flow is nothing but a fluid. This is termed here. A liquid is a fluid which is hard to compress. A given mass of liquid will occupy a fixed volume irrespective of size of the container. A free surface is formed as a boundary between a liquid and a gas above it. So now we go to properties of fluid. And before going to properties of fluid, first we shall discuss about classification of fluids. We are having 5 kinds of fluids basically. One is ideal fluid, real fluid, Newtonian fluids, non-Newtonian fluids, and pseudoplastic fluids. Along with them, we are also using compressible and incompressible fluids. So now first we shall discuss about ideal and real fluids. Ideal fluids are the fluids which have zero viscosity or no viscosity. In this natural, we don't have any ideal fluids because without viscosity, a fluid cannot be flown. So now next come to real fluids. Real fluids are the fluids which are tangentially shear forces apply or developed whenever there is a relative motion between a body. Thus, relative motion is said to be the fluid friction. So which means it is having a viscosity. So almost all the fluids are said to be real fluids. So this we can come when we considering this graph, the fluids movement will be taken with respect to velocity gradient. If the velocity gradient is uniform to the shear stress, then it is said to be ideal fluids. And the next is Newtonian and non-Newtonian fluids. Newtonian fluids and non-Newtonian fluids are the fluids. If the shear stress is directly proportional to the velocity gradient, then it is said to be Newtonian fluids. See, if we see this, there's a straight line between, there is a increase in shear stress with respect to uniformly with respect to velocity gradient. So such fluids are said to be Newtonian fluids. If there is a variation in and inversely proportional to velocity gradient, if the shear stress is, then it is said to be non-Newtonian fluids. And elastic solid or pseudoplastic fluids are the shear stress is very high when compared to the velocity gradient. And now what is a compressible and incompressible fluid? If the fluid is having a density parameter, then it is said to be a compressible fluid. If the fluids are not having a density parameter, then it is said to be an incompressible fluids. So now we shall go with the properties of fluid, and the first properties of a fluid is density, or it is said to be mass density. It is defined as the ratio of mass of the liquid by volume of the liquid, and it is denoted by Greek symbol rho, and the rho is equal to mass by volume. We all know that the units for mass is kg and the volume is meter cube. So the density units are said to be kg per meter cube, and the density of water is always 998 kg per meter cube. In general, we will be considering as 1000 kg per meter cube, and density for air is 1.2 kg per meter cube. So if we take a wood of 2 kgs and 4000 centimeter cube, that the density will be mass is given as 2000. So 2 kgs, 2 by 4000 centimeter cube. Then we will be getting the density of wood. Similarly, we can calculate for lead also. So this is sample example. And the next term is specific weight. Specific weight is next property of the fluid is specific weight. Specific weight is defined as the ratio of weight of the liquid per unit volume. So we all know that density is equal to mass by volume. So specific weight is indicated as small w, and this can be written as specific weight is nothing but weight of the liquid by volume of the liquid. So we know that weight can be written as mass into acceleration due to gravity by volume, and we know that mass by volume is nothing but density. So W, small w, can be written as rho into g. Here it is mentioned as specific weight gamma is equal to rho into g. So density of water is 1000 and acceleration due to gravity is 9.81. So we can take it as gamma of water, specific weight of water as 9810 or approximately 9790 Newton per meter cube. Similarly, for air is 11.8 Newton per meter cube. This is the second property of fluid. And the third property is specific gravity. The specific gravity is nothing but it is a ratio of weight density of the liquid by weight density of the standard fluid. And we will be considering the weight density of the standard fluid as water. So specific gravity is equal to weight of the liquid to be determined by specific weight of weight density of water is 1000 kg per meter cube. And for water, specific gravity is equal to 1, and for mercury it is always 13.55. Before going to the next property, we shall discuss one more important property, that is specific volume. Specific volume is indicated as small v, and it is just the reciprocal of mass density or density. So we know that density is nothing but mass by volume. So specific volume is nothing but the ratio of volume per mass, and it is denoted by meter cube per kg. And the most important property of the fluid is viscosity. It is nothing but just like friction in the solid mechanics or basic engineering mechanics. So viscosity is the measure of the resistance fluid flow as a result of intermolecular cohesion. So now let us consider a fluid is flowing with a velocity of v in this fixed plate, and the other there is another layer with respect to velocity of v plus dv, and the shear stress caused by the fixed plate to the moving plate and is determined with respect to velocity gradient, and the shear stress acting on the plate is nothing but tau is given directly proportional to velocity gradient dv by dy, and this is equated with respect to viscosity. So tau is equal to mu into dV by dy. This viscosity is also called as dynamic viscosity or absolute viscosity, where tau is here shear stress and v is dV is change in velocity and dy is the gap between the or thickness between the two plates. And the viscosity units are, we all know that units for shear stress is Newton per meter square, and we know that velocity units are meter per second, and the distance between two plates means nothing but thickness, that is meters. So if we cancel this, mu into second, mu by second, so if I cross multiply it, the units for viscosity are Newton second per meter square. So here it is mentioned Newton second per meter square, and then uh, it is also called as poise in CJ system. So that is given as 0.1 into Newton second per meter square. And next important parameter is kinematic viscosity. Kinematic viscosity is defined as the ratio of absolute viscosity by the density of the fluid, and its units are meter square per second, and it's in CSG system it is said to be Stokes. Okay, here it is here, meter square per second, and it is metric system, it is called as Stokes. So before going to the next property of fluid, whatever if the increase in temperature, whether the density will be increases or decreases for fluids and liquids, for fluids and gases we'll consider right now. Whenever there is increase in temperature, then the viscosity of the liquid will be decreases. Why? Because just now it said that in the viscosity is based upon the cohesion forces. So if the temperature increases, the molecule will be getting separated from each other, so that the viscosity will be decreases. Whereas in gases, if the increase in temperature means the molecular attraction between the molecules will become stronger, so that the viscosity of uh, gases will be increased with increase in temperature. In most of the university examinations questions, this was an important question which is being asked. What is the whether the temperature, if there is increase in temperature, whether the viscosity of liquid and gas will be increased or decreased. So we shall go to next property. Next property is the surface tension. So the surface tension, in better understanding, if you take three molecules in a tumbler, uh, just a second. If you consider a tub, and if you consider a molecule fully immersed in it, so that the upward forces will be equal to the downward forces. But when you consider a fluid at the topmost layer like this, the downward forces will be attracting the body to get downward. And if you consider half of the part like this, and this, the tensile forces acting on the surface of the liquid to pull out is nothing but the surface tension. So that is why I can mention a surface tension coefficients can be defined as the intensity of intramolecular traction per unit length along the free surface of liquid. This is the free surface of the liquid. So the intramolecular attraction between the molecules is said to be surface tension, and it is indicated with sigma, and in units are Newton per meter. So when you consider the surface tension, it will be considering with respect to a bubble or a hollow bubble or a liquid droplet, and the pressure force is equal to the tensile forces, so that we can be determining the surface tension for a liquid droplet and a hollow bubble. Next important property is capillarity. We all know the capillary tubes. If we see this is the capillary tube which is having a very less diameter. So, okay, here is a better understanding. So in a capillary tube is immersed in a liquid, what will be happening? There is a rise in a fluid or maybe a fall of a liquid within the tube. So if the rise of the liquid within the tube is said to be a capillary rise, and within the fall of a tube in a capillary tube is said to be capillary fall. And it is given as H is equal to 4 sigma cos theta by rho ZD. And theta is equal to 0 for water and theta is equal to 135 for mercury. And the next important property is compressibility. So compressibility is nothing but the reciprocal of bulk modulus. Bulk modulus, which we studied in the engineering mechanics and strength of materials, it is the ratio of change in pressure to the volumetric strain. And last important property of the liquids are vapor pressure. We all know that whenever we are boiling a water, there will be formation of water bubbles. And at the topmost layer, and if you continuously heating on it, what will be happening? It will be evaporated to the atmosphere. So the formation of those bubbles is nothing but the pressure is a partial pressure produced by fluid vapor in an open or closed container which reaches its saturated condition or the transfer of fluid molecules is at equilibrium along its free surface is said to be the vapor pressure. In the next class, we shall discuss about proper problems on these all the properties. And now we shall go with what are the basic units and systems. We all know the basic systems of units are length, mass, time, temperature, current, and luminosity. In the SI unit, it is length is meters, mass is kg, seconds for time, and Kelvin is for temperature, ampere for current, and luminosity is for candela. So it is indicated with L, M, T, theta, I, C, D. Derived units are the units which are combination of primary units. Okay. So SI units and US, where we will be dealing with international systems of units, that is SI. So for velocity, we know that meters per second and its dimensions are LT power minus 1. So these are the some unit conversions and their dimensions. These are the some important questions, the sample short answers and long answers questions which were derived, which was gathered from by me from previous question papers. Thank you.